Hello, my name is Eitan Suez, Technical Marketing Manager at Solo.io. In this lesson, we discuss the concept of shared gateways and demonstrate how this works hands-on. So if you recall, in previous lessons, we proceeded step by step from talking about the Gateway API to installing an implementation of the Gateway API using kgateway, and then we proceeded to demonstrate how to configure a gateway, provision it, program it, and then in the last lesson we sort of crossed over and showed HTTPS protocol. In this lesson we take yet another step and we give attention to the roles and responsibilities of users in the enterprise. And I think the best way to discuss this is through an example. So up until now, this is more or less the picture that we've sort of built up a single namespace in which we provision the gateway, and the gateway and the route was essentially created by the same user in the same namespace, without regard to the fact that there are multiple applications out there. Now, in reality, the picture is different. We typically have multiple application teams that each work in separate namespaces, as this diagram illustrates. And the setup for ingress is typically to have a single shared gateway with multiple routing rules that are defined in a self-service fashion by these respective teams, and they all get applied onto the gateway. And so this is the picture we're going to build in this exercise. And so we're going to use this as sort of kind of an itemized list of tasks we're going to create. We're going to deploy two separate applications. We're going to define 3 namespaces in total. We'll deploy a gateway this time to its own dedicated namespace. We'll call it the infra gateway, and then we'll proceed to create the routes, just as this sort of bullet list sort of iterates. So let's go ahead and jump to our environment and begin this work. Now, some of these things we've done before, and so they'll be familiar, and so I'll sort of run through them as they're relatively straightforward. So we need to create, so here we're assuming that the cluster operator team has its own area where it provisions gateways, and maybe it's a namespace called infra. So we create this namespace, and then application teams each have their own sort of area as well. So there's the HTTP bin namespace where we deploy HTTP bin, and the separate, I selected the Istio Bookinfo sample application as our other application that resides in yet another namespace, Bookinfo. So if we just take a look right now at our namespaces, we'll see 3, infra, HTTP bin, and Bookinfo. And if we look in each namespace real quick, we see different applications deployed to each of these namespaces. Now, we haven't yet provisioned our gateway. Since we're doing things properly using HTTPS, let's go ahead and create certificates. This time we'll need 2 certificates for 2 different applications. So just like we did in the last exercise, we generate a cert, and then we define a TLS secret in Kubernetes for HTTP bin. Now, I've chosen to put those secrets in the infra namespace. So I'm sort of deciding or making a design decision here that it'll be the job of the cluster operators to configure the TLS certificate for each application. And we do the same thing here for the Bookinfo application. We create a certificate and create the secret. Both are in the infra namespace. So now it's time to provision our gateway. Let's look at the gateway resource first. And this is not different from what we've done before. The main difference is the fact that there are a total of 3 listeners, 2 HTTPS listeners, each one sort of bound to a different host name, httpbin.example.com and bookinfo.example.com. They both reference a different certificate in their TLS configurations, and they both terminate TLS at the gateway. So we can go ahead and apply this, right? What could go wrong? and turn our attention to our routes. So if we look at the route for, say, HTTP bin application, this one would be applied by the application developers of that particular application in the HTTP bin namespace. Maybe let me backtrack for a second, and if we look at the pods in the infra namespace, we should see our gateway has been provisioned. Okay, so notice that the routing rule for HTTP bin references on line 11 the section name HTTP bin HTTPS. That's that particular listener that's tied to the HTTP bin host name. And the rule is, as it was before, to route those requests to the HTTP bin backing workload in the same namespace HTTP bin, listening on port 8000. So we can apply this route. I think that's this command. And if we look at the status of the route, there's different ways to do it. If we look at just the YAML, for example, we'll see an odd thing on line 37 through 39. Accepted is false, not allowed by listeners. So there's kind of a permission issue here that we sort of overlooked. And the main difference between this setup and what we had before is the fact that our gateway now resides in a separate namespace. So if we look at our gateway real quick, it's called infra gateway this time in YAML. We'll notice something rather interesting is that there are defaults. There's a field you see there on line 16 per listener called an allowed routes field. And the default is that the gateway will allow routes to attach as long as those routes are defined in the same namespace as the gateway, which is not the case. And that indeed is our problem. And so let us look at a slightly revised gateway configuration that takes this into account. And here again, we have to make some kind of design decision. We look specifically at the HTTPS listeners, and you see there, for example, on line 24, the allowed routes says namespaces from selector, where the namespace must have a label matching self-serve ingress equal true. So we decide that a label self-serve ingress equals true will give namespaces permission to attach routes from that namespace to this particular gateway. And that sounds like a plausible thing to do. And we have a similar sort of allowed routes clause for the other listener. Now for HTTP, we don't want developers to bind routes to HTTP. We don't want them to configure routes in the clear. And so we don't even allow that, and we don't change that default for HTTP. So if we now apply this particular updated gateway with allowed routes clauses and properly labeled each of the two namespaces with this self-serve ingress true sort of convention that I've sort of come up with, then when we actually look at our routes now, you'll see the status section should be a little happier. Here we see accepted true on line 37 and 38. So that's terrific. That means that our routes are now in place, at least the HTTP bin route. I don't know that I've applied it yet for book info. I'll do it in a moment. Here we do the application of the book info route. And here I provide a command that is really useful. It's basically looking at the status section of our infra gateway, but just picking out the particular fields I'm interested in looking at and verifying that there's one attached route for each of the listeners. So one for HTTP bin and one for book info. So that sort of validates that our configuration is probably correct in some respect. We still need to test everything and make sure that it works. So let's go ahead and do that next. Let's go ahead and grab our gateway IP address. Notice here we're grabbing the IP address of the gateway infra gateway in the infra namespace. Okay, and here let's make a request to HTTP bin, curl insecure HTTPS, and that seems to work. We can try the same thing with bookinfo. We make a request to the bookinfo.example.com product page endpoint. Here I'm just grepping for the HTML title just to limit the volume of the output, and they both seem to work. So there are two routes that each pertain to a different host name over HTTPS, done in a kind of a multi-tenant fashion. So the next step, or the final step I should say, is to really handle again the redirect for HTTP requests. That's more of a maybe a point of politeness. So let's look at a redirect route. This is very similar to what we did in the previous exercise. Maybe the main difference here is that we apply this redirect rule in the infra namespace. So this is something maybe the cluster operators will do for all of our applications. Notice the host name is star.example.com. And it basically says any request that comes in over this particular listener should be redirected to the HTTPS scheme. We can go ahead and apply that, and then finally test it. So here's a request to HTTP bin over HTTP, and we get back a 301 move permanently, and the location header is HTTPS. That's correct. We can test the same thing for Bookinfo, and we see the same thing happening. Another thing to take stock of before we sort of conclude this demonstration is the fact that we've created 3 separate routes that all bind to a single gateway. There's the Bookinfo route in the Bookinfo namespace, the HTTP bin route in the HTTP bin namespace, and then that redirect routing rule in the infra namespace. So here we have a shared gateway that is used by multiple application teams. Let's go ahead and wrap up our conversation. So the main lesson is that development teams can self-service the configuration of routes for their applications or APIs, while cluster operators can properly configure and secure their gateways and have control over how that gateway is configured. That concern is their concern separate from that of the development teams. And finally, we saw an example of how the allowed routes field allowed cluster operators to have a way to constrain which application teams have permission to attach routes to their gateway. All right, so that was a sort of slightly larger demonstration than what we've seen in previous examples. In the next lesson, we expand upon what we learn about the Gateway API by looking at the myriad of features that we can avail ourselves to when we work with HTTP routes. So we haven't looked at different kinds of filters, how we can do header modifications, URL rerouting, request matching, path-based matching perhaps, or header-based matching, and traffic splitting. These are all features that are part of the Gateway API, and it's high time we look at them in the next lesson. As always, thank you for your time, and we'll see you then.